So this is 2-4, quadratic graph standard format, and we have a function and 6 things we want to know about that function. So let's start with number 1. Number 1 is the axis of symmetry. And don't forget, when you have this quadratic in standard format, we could say A equals 2, B equals -4, C equals -1. Those are the 3 pieces of information that we can gather from this function. Ax squared plus bx plus c. So we know a, b, and c. So let's start out with the axis of symmetry. And the axis of symmetry is just the opposite of b over 2a, which using the numbers that we're given is going to be 4 divided by 2 times 2, which is 1. So the axis of symmetry is x equals 1. And we could graph that by putting a tick at 1 and drawing a line like this. X equals 1. That's our axis of symmetry. On the axis of symmetry is where the vertex lies. And so for part number 2, in order to find the vertex, we're just going to take x equals 1 and we're going to plug it into our function. We're going to find f of 1, -3. So that means our vertex is at the point 1, -3. So down here, 3 units, 1, 2, 3, right there. That is our vertex, 1, -3. So number 3, for the y-intercept, you know that x equals 0. So what you're going to find is f of 0, -1. And so that is our y-intercept, 0, -1, which is right here. And you could make a play on symmetry at this point, and you could actually put the symmetrical equivalent to the y-intercept over on the other side, if you wanted to. You don't have to. That's not a point we're really searching for. But sometimes it helps balance the graph a little bit. For part 4, we want to take the function and set it equal to 0. 2x squared minus 4x minus 1 equals 0. Technique number 1 is unfoil. So give yourself about 30 seconds, let the gears in your brain tumble around, and see if you can figure out the right combination to unfoil this. If you can't do it in your head after about 20 or 30 seconds, then go right to method number 2, which is the quadratic formula. Again, to review, the quadratic formula is x equals the opposite of b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And the reason I like to write it this way is because the front portion, this opposite of b over 2a, that is your line of symmetry. We know what that number is. We've already calculated it. We're going to calculate it again just to show you that it's the same. And then the plus or minus is how far off of that line of symmetry your x-intercept is. So the plus component is going to be the distance from here to here. This is plus square root b squared minus 4ac over 2a. And this is minus. This is the minus part. Negative, opposite of b over 2a is, okay. So we know a, b, and c from up above. Let's plug them in and solve this. And so we get x equals 1 plus or minus. And now we got to do a little bit of manipulation. The square root of 24, you can break the square root of 24 into the square root of 4 times the square root of 6, which then becomes 2 root 6. So now this becomes 2 square root of 6 over 4. And our final answer is going to be 1 plus or minus root 6 over 2. And if we wanted to estimate this, maybe we'll put a number 4 over here, we would say that your x-intercepts, the left-hand x-intercept, is going to be 1 minus root 6 over 2. And the right-hand x-intercept will be 1 plus root 6 over 2. All right, finally, we had 2 more things that we wanted to find out about this graph. If we go up here, number 5 and number 6. So where's this function, where's the graph greater than 0? Where does it have positive values? Well, from negative infinity up to the left-hand x-intercept, and that left-hand x-intercept was that big number down there, union with the right-hand x-intercept to infinity. Where's the function below the x-axis? And it's below the x-axis in between those two critical points, the left-hand x-intercept and the right-hand x-intercept. Okay, so this is how you find the characteristics of a graph that's in standard format. Let's do a little bit of a review from yesterday. What if we have a function that is not in standard format, that is in vertex format? So let's start with number one, the axis of symmetry. Now, from vertex format, you don't have an a, b, or c. Vertex format is a x minus h squared plus k. And in our case, a is equal to 2, h is equal to 1, and k is equal to negative 3. And this h and k are your vertex. That's why we call this vertex format, 1, negative 3. And so for part 1, finding the axis of symmetry, you don't have to do opposite of b over 2a. You just read it off the function. The axis of symmetry is x equals 1. That's h. Number 2, what's your vertex? I think that's going to be 1 comma negative 3 because the function's in vertex format, right? So those two are actually quite easy to do. Let's go to number 3. How do we find the y-intercept? Well, you have to do f of 0. The y-intercept is going to be at 0, negative 1. So maybe we should graph some of this stuff. So we'll put in our line of symmetry right here. X equals 1. Our vertex was at 1, negative 3, which is right here. And the y-intercept was negative 1, which is right here. So number 4 is finding the x-intercepts. So we're going to say 2 times x minus 1 squared minus 3 equals 0. Square root both sides. So that means for number 4, your left-hand x-intercept will be 1 minus root 3 over 2. And your right-hand x-intercept will be 1 plus root 3 over 2. You actually have two choices. You can choose to solve problems in vertex format or in standard format. You should know how to do both, but usually students have a preference for one or the other. If you take a look at the standard format work that we did on this problem, there was a lot of calculations. There was the quadratic formula. A lot of work, okay? That was standard format. We then did the exact same problem, solving for the exact same parameters in vertex format. And it seemed to be a little bit less calculations. And we didn't have the quadratic formula. And so, how do you go from one format to another? Here's vertex format and standard format. So let's say that you are given a problem that's in vertex format and you hate vertex format and you want to convert it into standard format. What do? Well, you just take your function and you simplify it. So you'd say f of x equals 2 times x minus 1 minus 3. FOIL this. Now you are in standard format. So in order to go from vertex format to standard format, you need to simplify. To go from standard down to vertex, you have to complete the square. So let's do that. First thing we have to do is divide everything by 2 because we need a lead coefficient of 1 in order to start the complete the square process. So now we're going to have x squared minus 2x plus blank minus 1/2 minus blank. So take your middle term, which is a negative 2, divide it by 2, that's a 1, negative 1, and then square it. So we're going to add 1 to this side, and we're going to subtract 1 to this side. And now, this guy, these first 3 terms, become a perfect square. they become x minus 1 squared. And then these two, you just put them together, and that's, what, negative 1/2 minus 1 is negative 1 1/2, which is negative 3/2. Remember when we divided by 2 way up in the very beginning? So if we divide by 2 at this stage of the game, when we come down here, we need to multiply everything by 2. And so you're going to multiply this whole entire thing by 2, which is going to give you 2x minus 1 squared minus 3. And you can see that's exactly what we had previously. So here's vertex format. It matches this. And here is standard format, and it matches this.